So for our second example, we're going to use power to find something else. Power, being able to know the power of something is really useful. In fact, we're going to look in a lab later in the week where we're going to use the power of a machine in order to figure out the energy involved, because that can happen. So in this case, we have though the power of a person. So a person is using 180 watts, but they're only 60% efficient, because you have to remember, when you run, you're not using all of your energy just to make you move. Part of it's going to go into your kinetic energy, 60% of it, according to this question, but you are also going to generate heat, and your heart's going to beat, and your lungs are going to breathe faster. All that is actually part of the power necessary for the running. So I'm going to start off by just taking that 180 whoops, that 180 watts, and figuring out how much of that is actually going into the running part. And it's saying it's 60% efficient, which means 60% of that power is going into what I want it to go into, which is moving me down the street. So of that 180, only 108 watts is going into actual running. So that's the first thing I need to know. The other thing I need to know is the time. And you have to remember, in the time, it needs to be in seconds for power. That's very important to get in your head. So I have 10 minutes of running, but I have 60 seconds per minute. So 600 seconds is what happened. This will now let me find the amount of energy, because power is energy over time. And in this case, the energy will be kinetic energy, because that is what we're doing, is running, and running will create kinetic energy. You'll notice we'll get a very high number because we're going to take 108 watts. Make sure you use the 60% one, right? Not the whole value. And we're going to use it to find the amount of energy, in this case, kinetic energy, that happens in those 600 seconds. So you'll notice big number, but we said energies are big numbers, and that's because a joule is actually not that big. So I get 64,800, and this will be in joules. Remember, sig fig wise, if I go back up and look at my question, I only get to keep two, right? 60% and 10 minutes both count. So I have to take that to 6.5 times 10 to the 4 joules. And that is what I would put in my therefore sentence.